I think we have a decent idea of how a signal is transmitted along a neuron. We saw that, a couple of dendrites, maybe that one and that one and that one, might get excited or triggered. And when we say it gets triggered, we're saying that some type of channel gets opened. That's probably the trigger. That channel allows ions to be released into the cell, or actually there are situations where ions can be released out of the cell. It would be inhibitory. But let's take the case where ions are released into the cells in an electrotonic fashion. It changes the charge or the voltage gradient across the membrane. And if the combined effects of the change in the voltage gradient is just enough at the axon hillock to meet that threshold, then the sodium channels over here will open up. So sodium floods in, and then we have the situation where the voltage becomes very positive. Potassium channels open up to change things again. But by the time we went very positive, then that electrotonically affects the next sodium pump, and then we have this situation where that will allow sodium ions to flood in, and then the signal keeps getting transmitted. Now, the next natural question is what happens at the neuron to neuron junctions. We said that this dendrite gets triggered or gets excited, and in most cases it's getting triggered or excited by another neuron. It could be something else. And over here, when this axon fires, it should be exciting either another cell, it could be a muscle cell, or in probably most cases of the human body, it's exciting another neuron. And so how does it do that? So this is the terminal end of the axon. There could be the dendrite of another neuron right here. So this is another neuron right there. I'm not drawing it that well, but I think you get the other idea. This is another neuron with its own axon, its own cell. And so this would trigger the dendrite right there. So the question is, how does that happen? How does the signal go from one neuron's axon to the next neuron's dendrite? And it actually always doesn't have to go from axon to dendrite, but that's the most typical. You can actually go from axon to axon, dendrite to dendrite, axon to soma. But let's just focus on axon to dendrite because that's the most traditional way that neurons transmit information from one to the other. So let's zoom in. Let's zoom in right here. This little box right there. Let's zoom in at the base, the terminal end of this axon, and let's zoom in on this whole area. And then we'll also zoom in. We're also going to get the dendrite of this next neuron, and I'm going to rotate it. Actually, I don't even have to rotate it. So to do that, let me draw the terminal end. So let's say the terminal end looks something like this. I've zoomed in big time. It looks something like that. This is the terminal end of the neuron. This is inside. This is inside the neuron. And then the next dendrite, let me draw it right here. The next dendrite, the dendrite of the next neuron. Let me put it right there. So we've really zoomed in. So this is dendrite of next neuron. This is inside the first neuron. So we have this action potential that keeps traveling along. Eventually, if we're maybe right over here, I don't know if you can zoom in, which would be over here, the action potential makes the electrical potential or the voltage potential across this membrane just positive enough to trigger this sodium channel. So then this sodium, so I'm really, maybe I'm getting really, maybe I'm really close. This channel is this one right here. So then it allows a flood of sodium to enter the cell. It allows a flood of sodium. And then the whole thing happens. You have potassium that can then take it out. But by the time this comes in, this positive charge, it can trigger another channel. And it could trigger another sodium channel if there's other sodium channels further down. But near the end of the axon, there are actually calcium channels. Calcium channels. I'll do that in pink. So this is a calcium channel. This is a calcium channel that is traditionally closed. So this is a calcium ion channel. Calcium has a +2 charge. Calcium ion channel. It tends to be closed, but it's also voltage gated. When the voltage gets high enough, it's very similar to a sodium gated or a sodium voltage gated channel, is that if it becomes positive enough near the gate, it will open up. And when it opens up, it allows calcium ions to flood into the cell. So the calcium ions, they're +2 charge, to flood into the cells. Now you're saying, hey, Sal, why are calcium ions flooding into the cells? These have positive charge. I just thought you said that the cell was becoming positive because of all of the sodium flowing in. Why would this calcium want to flow in? And